Okay, so today's lesson is on factoring. Again, the idea of factoring, we are trying to go from what we had as an answer like this here, x squared plus 3x minus 4, to this form, x plus 4 times x minus 1. So our goal is to basically find something that multiplies to give us the back number and adds to give us the middle. Now we're going to start when a is always 1. So with the snowflake method, here's what I do. I usually start by actually drawing this snowflake here. So then what I say is, okay, I need to multiply A and C together. We multiply those to get a number up here. Then we have our middle number, B. Then our middle number here is there. Now, if there is an A value, we put that here and here. What we're going to do is we're trying to find a number that multiplies to the top and adds to the bottom. So we want to multiply to what's up here and add to what's up here. So I'm going to write for the factors, we are looking for two numbers that multiply to give us the top number so we can, oh, sorry for misspelling multiply there. So you need to multiply to the top number and add to the bottom. Right now, just get this down again. This is one of those things. I'm saying things right now. This might make some sense to you, but the words are going to make more sense once we get going with some examples. And I got 4 examples for you. So just make sure you get this down. Again, I'm not saying this is impossible or actually that's super hard, but it takes practice. This is going to be a little bit of like a guessing and checking process. You're going to second guess yourself a little bit. We're going to use FOIL to check ourselves. I'm going to show us how to use Desmos to check ourselves. It's not the easiest thing in the world, but with practice, it becomes, okay, I got this. We are going to get into harder forms of factoring when A is greater than 1. I'm going to tell you right now, we're going to do that next week. When A is greater than 1, I wish I had this when I was in high school. I wish I knew of this organizational method, because when I was in high school, nobody had shown me this way to organize. And when A is bigger than 1, it's a little bit of a pain in the butt to factor. However, the snowflake method takes some of the guesswork out, or some of the guesswork out, takes a good amount of the guesswork out for when A is greater than 1 and actually makes life a lot easier for us. So remember, it always needs to multiply to the top and add to the bottom. Gonna get this. So that's okay. Gonna wait for you to be ready to move on. The next slide is going to be tips for us, because what's going to happen here is another thing that students had trouble with, or the signs. What should be positive? What should be negative? And the next slide gives you all those tips and tricks. So to figure out when numbers seem to be positive and negative is another thing that really trips up students on this. And for good reason. I'm not saying it's super easy to figure it out, but if you follow my tips that I'm about to give you, it is a little easier and should help you out.
Not covering now, not 8:45.
It wasn't just a long time. Okay. Cool. Okay, let's take a look at these tips and tricks I was talking about. So, getting this right, it's a little bit of guessing and checking type thing, just making sure you got it. Here are some tips though. If both your B and C value are positive, both factors are positive, so you're going to have it x plus something, x plus something. Now, if B is negative and C is positive, it's going to end up being x minus and x minus. The reason it ends up that way is because a negative times a negative gives you that positive C value. But when we add two negatives together, it remains negative. Now, when C is negative, this is where I can see students getting, or this is where I see students typically getting tripped up. If C is negative, one of my numbers has to be positive, one has to be negative to multiply to give me a negative. So here, the sign of B is going to be critical. If B is positive and C is negative, the bigger factor is positive and the smaller is negative. So it's going to be x plus the bigger factor that you find and x minus the smaller factor you find. When both B and C are negative, that switches. Now the bigger factor is negative and the smaller factor is positive. So again, these are some tips and tricks. I definitely recommend writing them down, including what I'm putting at the end. Is what I'm putting at the end. What I'm putting at the end is kind of how it's going to look, okay? So make sure you got this down. If you have questions, please just hold them until we at least look at the first example, okay? Right now, just get it down so you have your notes. Where you need to head? What room are you heading to?
I don't know his name. He's like right over there.
Thank you so much. Thank you, Alexis. We're just in our notes. Yeah, you see. The number of people still writing. This is going to be really helpful. So usually, not usually, always when we're looking at this, we're going to start by looking at the C value, that number that's going to be on top of the snowflake. Because if I'm thinking about whole numbers, if I'm trying to add to say, give me 12, there are a lot of different ways to add to give me 12. I could do 1 plus 11, 2 plus 10, 3 plus 9. You get the idea there. I could also throw negatives in there. I could be like 13 plus -1. So when we're trying to add to the middle number, there are a lot of options there, right? However, when I try and multiply, let's again use that same number, 12. If I'm trying to multiply, if I'm multiplying to get to 12, I have very few options. I have 1 times 12, 2 times 6, 3 times 4. Now I could make all those options negative as well, but that's a lot less options than are adding, right? So that's what we're always going to look at first is, hey, what multiplies to give us, in this case, just the C value or whatever that top number is. So the C value is where we're going to start looking because we're keeping all our A values at 1 today, which makes life a lot easier. You're going to see on Monday and Tuesday when we expand that, oh yeah, when A is not 1, life does get more difficult. Okay, looks like most of the writing has stopped, or all the writing has stopped. Let's take a look at the first example. First thing I want to do is just set up my snowflake. Now, is there any number in front of it, in front of x squared? No, there's no number in front of x squared, right? So again, life's a little easier here. So I'm going to start with the snowflake. Since there's no number in front, A is 1. 1 times 12 is 12 up here, and 7 on the bottom. So let's start here. What numbers multiply to give me 12? Multiply. So 6 and 6 would add to get there. So that'd be like 2 times 6, 1 times 12. Good. And what's another combo? 3 times 4. All these combos. Do we see one that could either add or subtract to give me 7? 3 and 4. So that's our magic pair here. Thank you, Taylor. So I'm going to put 3 and 4 here in my snowflake to be like, okay, that's what I got. Because yeah, 3 times 4 gives me 12, but 3 times 4, yeah, gives me 12, and 3 times 4 gives me 7. Other combos don't work because if I use 1 and 12, yeah, it multiplies to this, but that would add up to 13, and that's not what I want. 2 and 6 would add up to 8, and again, that's not what I want. So once we do this, now when ones are on top here, we got no stress. I'm just now going to write it as x plus 3 times x plus 4. If we were to do FOIL on this, it would return to this problem right here. So FOIL is one way to check. I'm going to give you another check using Desmos. It's actually the exact same way we checked our work with FOIL. Now, I think with FOIL, you guys, once you got the hang of it, you're like, checking it, I don't need to do that. That was easy. However, I think with this, you're going to want to check it for a little longer and try and make sure you got it before we just say, oh, I'm good without checking, because this is a little bit more of like a guess and check type process. You might not always find that first pair right away. Sometimes you might have to think a little bit and think through a couple different pairs before you get there. So here's how I'm going to check this in Desmos. So what I'm going to do is I'm going to first graph the original equation, x squared, not x to the 7th, x squared plus 7x plus 12. So that's what my original graph looks like. Then I'm going to take my answer. If I have factored it wrong to be like, oh, x plus 2 times x plus 6, notice this black graph and the purple graph, they don't match up at all. However, we didn't say it was 2 plus, or x plus 2, x plus 6. We said it was x plus 3 and x plus 4. And now the purple and the black graph line up. So I know I factored it correctly. If I accidentally mess up my signs, it was like -3 and -4. We notice again some similarity to the shape, but it's not in the right spot. So that's a way we can check ourselves. Right now, before we move on to example 2, do we have any questions on this first example? Okay. I know one's not enough for this, so let's take a look at the second one. So 1 times 20, that's 20 for a top, 1 and 1 on the sides, and -9 on the bottom. What multiplies to give me 20? 10 times 2? What else? 4 times 5? And of course, 1 times 20. So looking at these combos, does anybody see a way to make a 9? Don't worry about the sign right now. Just does anybody see a way to get to 9? 5 plus 4, yeah. Now, if I want it to be a -9, what should both of these be? Yeah. So it's going to be -4 and -5. Because -4 times -5 gives me a +20, right? And -4 plus a -5 gives me -9. So, look, when I was in high school, this was very much, I didn't have this nice organizational method. So it was very much, I'm just thinking it through all of this in my head without having something to keep my ideas organized. So we were just had to ask ourselves these questions in our head. I really like this because it helps you organize those thoughts and questions you're trying to ask. So it will be x minus 4, x minus 5. So again, I'm having confidence in what I'm doing, but I still want to check this. So again, on Desmos, I am going to graph this original equation and the new one I got and make sure those graphs align, just like we did with checking that we did FOIL correctly. We took our answer in the original and compared.
Check that email from Nurse Davenport and send those students to 208. That would be great. You can check that email from Nurse Davenport and send those students to 208. That would be great. You can check that email from Nurse Davenport, please. Thank you.
So I will check that email while you quickly get the end of that down. When Alex gets back. So my original equation had said x minus 9 or x squared minus 9x plus 20. So that's, we're seeing there. Hey, we saw this answer actually wasn't horribly off, but it was still off. So here I had actually put x minus 4 times x minus 5. And there we go. We get again the purple and black graph are matching, so I know I did it correctly. Then we can find where the zeros are by clicking on them if we wish to do that as well. So, any questions on example 2? Now, I really recommend for all these that definitely today we're writing out our full list of factors for the number on top and definitely doing the Snowflake method. Look, right now you might say it feels a little cumbersome doing it, but that's why I want you to practice it to make sure you're getting the idea down. Because I'm going to tell you, right now, when we get into an A is greater than 1, if you're getting used to using the Snowflake, it's gonna make life easier. If you're trying to do the Snowflake for the first time on there, you know, you're taking 2 things on at once instead of just one. See a few pencils moving, I think. Example 3. This one, my C value is negative, so I have to be a little bit cautious with it. Again, my tips can help me with that. So my bigger factors should be positive, my smaller should be negative, because B is positive and C is negative. So again, start with setting up my Snowflake. That's going to be negative 28 on top, 1 and 1 on the sides, 3 on the bottom. Now, what multiplies to give me 28? 1 times 28, that's the easy one, good. And do not forget about that combo as well. Sometimes that does come up depending on how we're doing this. So never forget about 1 times the number. What else multiplies to give us 28? 4 times 7. There's one more combo in here. 2 times 14. Good. So, out of this group of numbers, can anybody think of a way to make a 3? 7 minus 4 gets me 3. And if it's a positive 3, we want to keep that order of 7 being positive and 4 being negative. So I'm going to say positive 7 and negative 4. Because 7 times negative 4 gets me to negative 28. And then they add to give me 3. And again, B is positive, C is negative. If we quickly go back to my notes here, the bigger, when B is positive and C is negative, the bigger factor is the positive and the smaller is the negative. So this ends up factoring to x plus 7, x minus 4. So we're going to look at, again, the visual of this. And I know when that C value is negative, that's where we're going to get more errors happening. I'm going to show you how we can look at the graphs and see how the errors might happen there. So my original equation said x squared plus 3x minus 20. So that's what my original looks like. Or no, not minus 20, minus 28. Now I need to put my answer in here. So the correct answer we got, we said plus 7 and minus 4. So we notice that this is correct right now. But let's pretend we have made a mistake. Let's pretend I said, oh no, the 7's negative and the 4 is positive. So see how when we look at this, it kind of looks correct. I'm going to actually zoom out a little bit more on these ones. But it actually just kind of looks like it gets flipped over the x-axis, or not x-axis, sorry, the y-axis. Like if I flipped this over the y-axis, it actually looks like they might land on top of each other. That just tells me my signs are backwards. If I had chosen a different combo that was wrong, like say 2 and 14, we see that this looks rather different, right? But that 7 and 4, even though the signs were wrong on this one, it looks kind of close. So my guess is, wait, I'm going to try and refix those signs, make it positive and make it negative. So another way you can do it, so see how I was just editing in here and changing up things in there? You can do it that way as well. When you're trying to check these, you can do a little bit of guessing and checking that way. I'm trying to help us so we're doing less guessing and checking, but that's a valid way to kind of guess and check your way to like, hey, how am I getting this? Any questions on example 3? We got one more example for today. This one, both B and C are negative. So it's negative 48 up top, 1 and 1, and then negative 8 on the bottom. So 48's a bigger number. We should have a longer list, right? What are some numbers that multiply to give you 48? 8 times 6. But that is a valid combo. 6 times 8. Okay, what else? 4 times 12. What else? 48 times 1. Good. 2 times 24. Then there's one more in here. 3 times 16. Perfect. So now again, I'm looking at each pair of numbers. Does anybody see a way to get to an 8? We'll worry about the sign in a second, but any way to get to 8. 12 minus 4 gets me positive 8, right? But if I want it to be negative, how would I write it? Negative 12 and positive 4. So again, when I said they're both negative, the larger factor is my negative and the smaller one is my positive. So negative 12 times 4 does give me negative 48. Negative 12 plus 4 gives me negative 8. So that gives me a final answer of x minus 12 and x plus 4. So we'll check that in just one moment. Thank you. So see writing happening. I'll flip over to Desmos once I see some more of the writing stop. Don't want to cut you off in the middle of what you're doing. Let's take a look at checking our answer using Desmos. And again, today, I'd really recommend you use Desmos to help you out with checking your answers, just because, I mean, this is not like easy and simple stuff. So, there is a lot of guesswork. It's easy to make mistakes in here. Well, actually, I want to zoom this one back out again. So I zoom out so I can see the full thing. My purple and my black are indeed coinciding. So I know I have factored this correct. Again, if I had gotten my signs backwards, we will see that this graph looks kind of right, but just a little bit off. So now I can correct back and see how that changes. So I want you using Desmos to help you out. I want you using all the resources you have. I'm here, Mr. Vaughn's here. We're here to help you guys. I know we don't have a ton of time left in class, but we have enough time to get started. So let me stop share. Stop recording.